Hi students, another video lesson for you from Mrs. Derby. Today we're looking at Unit 2, Lesson 11. And there's two actual videos about this same concept here because there's two different ways that we can approach the math. So if one way makes sense for you, stick with that way that you're doing it. And if it doesn't make sense, or if you just want to see what the other method is, make sure you watch the other video to also check out a second way that you could go about doing it. And we record these videos and have them up on our classroom in case you want to watch this twice or another time at home to slow it down and see some of these steps again. So let's get going in our Unit 2, Lesson 11. We're talking about where two sets of polynomial graphs are going to intersect each other. Now, a lot of times with straight lines, we could find where they were at the same place at the same time. And we can do the same thing with polynomials, whatever the shapes of those graphs are, and how they can intersect with another one. So we're going to start with question number 2. And we're going to look at the first method that we would use to possibly solve this. And the way that we would use is by using some subtraction. So this is our subtraction method. Now the first thing that you should always check for is if you have anything similar between the two sides of the equal sign, right? If we want to find out where an equation f is at the same place at the same time as equation g, we can actually put these two polynomials equal to each other, because if we want them to be at the same place and at the same time, that means they need to have the same x and y coordinates at a given point. So we can set them equal to each other. So I'm going to say this is where f equals g. I've taken my f equation and I've set it equal to the g equation. Stop, and the first thing you should always check is if they have something in common, an entire factor. So I notice this x minus 4 is a common factor on both sides. That tells me that when these two are happening, right, when these two graphs are going on, there's immediately a factor that they have in common. And that factor, turned into a 0, is what's going to give us one of the answers to this equation. So we've already talked about turning factors into zeros and zeros into factors. What we see is that each of these has a factor of x minus 4, and that means each of these is going to have a 0 at x equals positive 4. So wherever these two graphs are happening, here at positive 4, both of these graphs will be moving into this spot. So one of them may be a parabola that is going through that spot, whereas the other one is maybe a straight line because it only has one term going on here. And so maybe it looks something like, well, it couldn't look like that now, could it? Because that looks like it's it's intersecting 2 times. So right here, this 0 spot at positive 4 is one of the places where both of them are in common. So please check first for a common factor, because automatically we know one of the places that they intersect is when x equals 4, and it's happening at the ordered pair 4, 0. We know that because it's a 0, and all of our zeros happen right on the x-axis. If I were to plug in 4 into this equation on both sides, in place of all the x's, we would have 11 times 0, because 4 minus 4 is 0, equals 0, because again, plugging in 4 for x, 4 minus 4 is 0. 11 times 0 is 0, and yes, this checks out, that 0 equals 0. We do in fact have something in common that makes both sides true at the same time. Now, we found one of our factors, but it looks like when we draw this line going in here with the parabola, it intersects a second time. So I need to find where this second intersection is happening. this is where the method of subtraction is going to come in. If I subtract this x minus 4 factor from both sides, using our algebraic thinking that we use, I can definitely do that, and what I have left on the right-hand side of this equation is nothing. I've subtracted that x minus 4 away. And what I have on the left-hand side is still the x plus 7 times x minus 4, and now subtracting an x minus 4. Now thinking again about common factors and factoring something out, it's like we have reverse distributive property. I see x minus 4 in each of these two terms. So I'm going to factor out an x minus 4. If it's showing up as a term in each side or a factor in each of these two separate terms separated by division or by subtraction, I can factor out that x minus 4, and then I can think about what it has to multiply by to get back to where I started. So up here, in this first term, it has to multiply by x plus 7. I already have the x minus 4 here that's matching and is being factored out. That x minus 4 is multiplying x plus 7. Now in my second term here, I have already factored out that x minus 4. It's here in front. So we can think of this like it's got a 1 in front here, right? Minus 1 times x minus 4, that term. So the only thing that it's multiplying against in the second term here is a negative 1, or a minus 1. Subtract 1. So again, we're kind of doing that reverse distribution. You can see that if I took this term and I factored it, I could multiply it these two times and get back to here. But we're first of all subtracting that x minus 4 from both sides, and then we're factoring out the x minus 4. Simplifying what we know we can simplify, x minus 4 in the first factor is going to stay exactly the same, but the second factor I can simplify to x plus 6 equals 0. Now again, knowing what our possible connection is between factors and zeros and how we can switch between those each time, we already know that we can take each factor separately and set it equal to 0 to figure out what x would make that true. So in this first case, we already found out that x could equal a positive 4. We already know that because we said, hey, check that factor first, see what x can equal. But here it is, our second factor, this x plus 6. If I set that equal to 0, because anything times 0 is 0, and if this factor equals 0, whatever I multiply it by will be there as well, and I subtract 6 from both sides, I see that my other answer happens when x equals negative 6. So here is where I'm finding that second answer, x equals negative 6. To find out the ordered pair, what the y coordinate would be when x is negative 6, I have to go back to the original equation up here to see what it would equal. And I can plug that negative 6 into either equation to figure out what my output, what the y would be. So in order to find this y, I have to actually plug it back into the original. And I'm going to do it to both sides in this first example just to show you that they should be equal to each other. So if I plug in a negative 6 plus 7 multiplied by negative 6 minus 4, I need to find out what this output would be. Negative 6 plus 7 is 1. Negative 6 minus 4 more is negative 10. And 1 times negative 10 equals negative 10. There's my output. There's the y value. if I really want to double check and make absolutely positively sure, I should also be able to plug it into the second equation, which is just x minus 4. Again, I know that x is negative 6, so negative 6 minus 4 in the g equation equals a negative 10. So I'm getting that same output value. Okay, we have a match here. That means it has to be our answer here. All right. So to summarize, we used subtraction to move a factor from one side to the other side. We then factored out a common factor, and then we moved forward from there. All right, so there's our first example with subtraction. I'm going to work through another example just to make sure you've got the idea. All right, looking at the second question that we have, I see that this one also has something where they have a common factor for each other. So this one, they each have an x minus 4. Now I always want to start off by remembering that that common factor is going to also start off with a common answer. So a factor happening at x minus 4. We already know factors and zeros are very closely related. These both have a factor at x minus 4, so they both have a 0 at x equals positive 4, x equals 4. All right. So we know that both of them have one of these answers in common at 4, 0. That is one of my answers. But I need to look for another answer. Okay. So what we would do here with subtraction is to subtract. If these two things are equal to each other, I'm actually even going to draw over it with a giant black equal sign. These two equal each other. All right, nice dark so you can see that they equal each other. One way we could go about this is to actually subtract one whole side. So I'm going to actually subtract both factors out now. This whole entire side, and I'm going to subtract it from our other one. So we would have x plus 7 as a factor times x minus 4 as a factor, and I am going to subtract the entire second side, 2x plus 5 and x minus 4. And that leaves the right side of this equation equal to 0 because I've subtracted everything away from it. All right, so we're going to set it equal to 0 because I've subtracted everything on this right side away completely. And again, I'm looking for that common factor, and I'm going to factor it out of the equation. They both have an x minus 4. So let's factor out an x minus 4 and see everything that I have left. In the first part, I have an x plus 7 left. And in the second part, I am subtracting, and I need a second set of parentheses here, a 2x plus 5. I need that second set of parentheses because I need to make sure I distribute that subtraction. Please don't forget that step right there. Pretty common error that happens for some students. Is forgetting that. So we need to distribute that subtraction that's happening here to each of the terms going inside. All right. So we still have that x minus 4 in parentheses, the one factor that hasn't changed because it's the same thing we have in common on both sides to begin with. And I have an x plus 7 minus 2x minus 5. And I need to start using that skill of combining like terms to see what I can add and what I can't add, what I can subtract or not subtract. X minus 4 still staying the same. And in my second set of parentheses, I had an x and I'm subtracting 2 x's away from it. So that leaves me 1 negative x. I have positive 7. I'm subtracting 5 away from that. That leaves me with a positive 2. Now again, I already know one of my factors has to be a positive 4 because of that common factor that they started with in the very beginning. So I can look at this like x minus 4 equals 0, and I can solve to figure out that one of my x's has to be a positive 4. And then on my second factor, I can set negative x plus 2 equals 0. This time I'm going to add the x to both sides because right now it's negative. I like working with positives better than I like working with negatives. And I find out that my second x equals 2. So one of my points of intersection is at 4, 0, the common 0 that they already had. One of my other answer, not one of my other, but my other answer is that x equals 2. And I have to find out what my output is. What is the x coordinate that goes with it? The only way to find it is to plug it back into the original. So I can plug it into either side and check it. So plugging in 2, I'm going to work here on the right hand side just because it's closer to where I put my answers. 2 times 2 because x equals 2 here, right? So I'm substituting this 2 into x in place of x. Plus 5 times 2 minus 4. 4 plus 5 is 9 times 2 minus 4 is a negative 2. This gives me an output of negative 18, and that tells me my y coordinate for this point. So I found both of my intersection points. If I wanted to check, I could use a graphing calculator, or I could use Desmos just to make sure that they are absolutely positively spot on correct. And in fact, I went ahead and did that just so I could really check in my Desmos. I'm going to call that up really quickly. I took my original two equations, x plus 7, x minus 4, and 2x plus 5 times x minus 4. And I graphed them in a Desmos just to see what they looked like. So here are those two equations. I have a red and a blue one. And when I look for points of intersection, it helps me out in Desmos because I can click on those two graphs and I can see what they actually have, both of them in common. And they both have a point of intersection at 4, 0. Now our other point that we have looks like it's down here somewhere. If I zoom in a little bit, I can see that at one point the blue graph is a little bit below the red graph. And if I look for that point of intersection, it also tells me it's happening at 2, 18. So mathematically, we can still solve this even if there's only one factor in common and we have two factors on each side. Now let's go worst case scenario. What happens if we have two sets of factors and absolutely nothing is the same? A couple things could be happening here. We could have a couple graphs that intersect the whole time. So let's say that we have an ordered coordinate grid like that, and we have one that looks like this. We could have a second one that is always outside it and below it. They may never intersect each other. We could have a point where they intersect one time. Maybe it's one answer. We could have it where they intersect 2 times. Maybe it's 2 answers. Or we could maybe have simply 2 different ways to write the same line, and it's an infinite number of answers. All right. So this one has a lot of different possibilities, and we have to see which one is true. But we might only find one answer here, or we might not find any answers. So here, one of our fastest ways to do this is actually to not use subtraction. Because even if we subtracted things from each side, there would never be a common factor for us to find that would make that true. So instead, we're going to use our multiplication. So we're going to multiply binomials together, polynomials together. Polynomial multiplication. This is why we had to make sure we knew this skill first. And I'm going to trust you to go ahead and be doing this grid to multiply it all out. I'm going to follow it through on this side, but on our right hand side I'm going to do it a little bit faster. So if you need to hit pause and calculate it yourself, you certainly could. I have an x squared, a 1x, a negative 8x, and a negative 8. So on the left side of this equation, multiplying this all out, I would have an x squared minus 7x. Remember, you're combining like terms from your grid. And it would equal x plus 2, x minus 4. Complete that whole grid. Alright, so if you completed both of those multiplications, you'd have something like this where these two polynomials would be equal to each other. And now we can still use our algebraic thinking to move things from one side to the other in order to combine like terms. Our goal is to move everything from one side to the other in order to set it equal to 0. Then we're going to see if there are any zeros of that graph and if we can ever make it happen. So, first up, let's subtract an x squared. Let's get rid of our highest degree. Those will cancel out. I'm going to add 2x to both sides to cancel it out here on the right hand side. So I'm going to add 2x over here. You could move everything from the left to the right instead. You could certainly do that. I just chose to get rid of everything on the right hand side. Finally, I need to add 8 to both sides and see what everything equals. Now we already said our x squared terms canceled out. On the right hand side, all of my terms are canceling out and I'm left with 0. On the left hand side though, I have negative 7x's and I'm adding 2 x's to it. I have negative 5 x's going on here. And I have a negative 8 and I'm adding 8 to it. That winds up as a 0 as well. These two are going to cancel out. So all I have is a negative 5x equals 0. Divide both sides by 5x to get, negative 5 to get the x by itself. And 0 divided by negative 5 is going to equal 0 all day long. So this happens when it's heading through the origin, actually. We have an ordered pair answer that's going to have 0 as our x-coordinate. To find our y-coordinate, we have to plug that 0 into either equation in the original. You've heard me say that a couple times before. So I have a x equals 0. I'm going to plug it into the left-hand equation, this one here. And so I have 0 plus 1 and 0 minus 8. 0 plus 1 is 1 times 0 minus 8 is a negative 8. This one equals negative 8. So there is our output, our y-coordinate. So this one only has one intersection point between these two graphs, and it happens at 0, negative 8. Again, if you need to watch this video a little slower about how we subtracted things and then factored out the common factor, you can certainly do that. Or maybe you want to check out the other video that we have that shows you a different way using division instead of subtraction. I do tend to like that one a little bit better, I'm going to be honest with you. But which one you choose to use is really up to your choice and your taste. Alright, good luck. Thanks.